Bismillah ar-Rahman ar-Rahim. Hello and welcome to another video of the book Code Complete. In this video we're going to talk about chapter 20, the software quality landscape. Well, here are the topics that we're going to be discussing here. First, we're going to talk about the characteristics of software quality. Then we're going to talk about the techniques that we can use to actually improve software quality. Alright, the third topic, the third point is going to be the relative effectiveness of quality techniques. Then we're going to discuss when should we do quality assurance. And after that we're going to talk about the general principles of software quality. And after that we're just going to wrap up. We're going to revise most of the concepts that we've talked about in the video, just like any other chapter. Let's go. Alright, so first we're going to talk about some characteristics of software quality. Well, software has both external and internal quality characteristics. External characteristics are characteristics that a user of the system or software product is aware of. You know, something the user can actually touch or feel. Here are some of those characteristics. Well, first of all, we have the correctness. Well, correctness means simply the degree to which a system is free from faults, from errors. Simply, a system is correct. That means the system is most likely to produce correct results. Does what the user of the system actually expects it to do. Another characteristic is usability. Usability means actually the system is easy to use, to learn and use. That's usability. Another great characteristic is efficiency. Efficiency, that means the system actually, the program, the software uses minimally set of the system's resources. That means that in order for the software to work, it doesn't really use much memory, or it doesn't take much execution time. It is efficient. It uses little resources to actually do its job. That's efficiency. Also, a very great external characteristic is reliability. Reliability means the system is able to perform its required function under stated conditions whenever required. That means whenever I need to use the system, I have a certain degree of confidence that the system will actually work and do what I expect it to do. So that's where we say a system is reliable. Another external characteristic will be integrity. Okay, what do we mean by integrity? Integrity means the degree to which a system prevents unauthorized or improper access to its programs and its data. The system is capable of protecting itself, its data, and its state from unauthorized access or improper, manipulation. It has the ability to protect your data and to protect itself from unauthorized or malicious access or activities. Also, we can talk about another external characteristic, which is accuracy. Accuracy means the degree to which a system is free from errors. That means it's accurate. It's like just we're talking about anything else. If you say somebody's accurate or some estimation is accurate, that means it's as close to the right value as possible. So that's an accurate system. An accurate system is a system that produces results that is most likely to be correct, or it's the closest thing to right or perfect results. Alright, we're now going to discuss internal characteristics. Okay, in contrast to external characteristics, as we mentioned, external characteristics mostly care about what other people feel about the program. Internal characteristics is all about the programmer, the person who actually wrote the code. So programmers care about the internal characteristics of the software as well as the external ones. So here are some of those internal characteristics that coders, programmers care about. Well, we have maintainability. Maintainability means the ease with which you can modify a software system to change or add more new capabilities. If your system is very difficult to modify, you cannot add to it, you cannot fix it, you cannot change it. That means it's bad. Its maintainability is very low. We need to make it high. That means whenever we need to add something, whenever we need to fix a bug, whenever we need to change something, it will be easy. It's not going to be a problem. So that's maintainability. Another internal characteristic is flexibility. Flexibility means the extent to which you can modify a system for users or environments other than those it was specially designed for. I mean, if you wanted to create a system for a specific environment, alright, let's say you're building an ERP system for a bank, and then you wanted to use this ERP system but for another type of industry, for a manufacturer, for example. If the additions that you can add to your system is minimal, that means you can just do little work, little modification in order to make it work in other scopes or in other systems or in other environments other than the ones that you first had in mind when you made the system. That means that your system is flexible. But if your system is the kind of system that it can only works, you had a specific environment, a specific circumstances in mind, you use that, you made your system works in those environments, and you want to transfer it to another environment. If it's easy to do this transformation, that means your system is flexible. Otherwise, it means it's not flexible, and you need to make it as flexible as possible. Well, another internal characteristic is portability. Portability means that the ease with which you can modify a system to operate in an environment different than for which it was specifically designed. You can just, it's portable. You can actually move it from one place to another. This is the difference between portability and flexibility. Flexibility is all about extending the current system to cover new situations. Portability is about taking your system into another environment and try to run it there, to make it work there. Okay, another characteristic is reusability. Well, reusability is it's all about the framework, or the company as a whole. I mean, if you write code right now and then in maybe a year later you had a new project, okay, and you think like you can use some of the code that you wrote for a previous project in the new project instead of just writing it all over again. If you can use the code that you wrote for a certain project in another project, that means your code is reusable, and it's a great thing. But sometimes there is certain types of code when you feel like this could only work in this code for this particular environment because it was badly written. It wasn't carefully written. But if it's well written, that means you can use it in other situations with similar requirements or similar cases. Another internal characteristic which is very important, and actually it's one of the main focuses of this book, is readability. Readability means that your code is readable. That means if somebody's not you, or maybe it's you, but maybe in a month or 2 months after you finished writing the code, and then that person went through the code again, he or she would be able to understand it. It's readable. So you have to strive to actually maintain readability. Another great internal characteristic of software quality is testability. Testability means the degree to which you can unit test and system test a system. The ability of the system itself to be tested. Right? Because sometimes the code is written in a way that it is very difficult to generate a test case or to run it. You have to write your code with testing in mind. When you write a piece of code, you have to think about how would this be tested. Alright, we discussed some of the characteristics of code quality, right? Terms or characteristics that could actually tell you if the code is of high quality or not. Now we're going to talk about some kind of techniques that we can actually use, stuff that we can do to improve our code quality. Well, here are our bullet points, and we're going to be discussing them one by one. The first point is that you have to set some software quality objectives. In order to enhance the quality, you have to set some objectives, alright, to achieve. This is a very powerful technique for improving software quality. You actually set explicit quality objectives from among the external and internal characteristics that we have talked about before. Without goals, you cannot measure your progress. You cannot measure your quality. You cannot tell if you're actually achieving more quality or not, because you don't have explicit, clear, bright, obvious goals. A second technique is that you have to explicitly define your quality assurance activities. There is a common problem in assuring quality, is that quality is perceived as some kind of a secondary goal. The first goal would be to actually get the thing to work, and then after that, when everything is working, then you strive to achieve some kind of quality. And this is a mistake. In some organizations, actually, quick and dirty programming is the rule rather than the exception. And I think most of the organizations, to be honest, do that. They want to do the thing, they want to make it work, they want to make it fast, and they don't really care about quality. Of course, it comes and bite them in the backside, but they don't care about it right now. So it shouldn't be actually surprising that programmers don't make quality their first priority, of course, because they be caring about the deadline. You care much about developing, deploying the thing on time and everything. But you have to care about quality because eventually you will come to care about it. It makes you feel it makes your job much easier. When you have your code, it's readable and it's testable and everything. It's just less headache. So you have to explicitly define your quality assurance activity. You have to write it down. What should you do in order to achieve quality? Also, we're going to talk about testing strategy. Execution testing can provide a detailed assessment of a product's reliability. Of course, since reliability is all about getting the product to do whatever it's supposed to do, so testing is the measure of that. We're going to talk about that further in this book. But testing strategy, defining a clear and concise testing strategy, is one thing towards quality because it helps defining the reliability and the correctness of your system. Okay, another way or technique that you can do to actually improve the quality of your code is to follow software engineering guidelines. Well, guidelines should control the technical character of the software as it's developed, of course. Well, guidelines apply to all software development activities, including starting from the requirement definition, from the requirements phase into the design phase, into the coding phase, the testing, and all the other phases that follow. You have to follow guidelines. If you follow guidelines, you will make sure that you develop quality software, because the guidelines are best practices, stuff that has been agreed on by experts in the field after years and years of practice. And well, there are technical reviews, either informal or formal. Informal technical reviews will be after you finish your work, before actually delivering it to people, you can just show it to a couple of your mates. They can review it, they can talk to you through it, they can give you advice about stuff that you need to change. This would be a friendly informal technical review. But after you're giving your informal technical review, then the code has to be formally reviewed to make sure that it actually follows the quality and the standards required for this project. Also, after that, you can use external audits. You of course you can use an extra set of eyes on your code. People who were not biased anyways to or against your code. People who are just from the outside. An external audit is a specific kind of technical review used to determine the status of the project or the quality of the product. The benefit of the external audit is, as I said, he's not biased. He's not feeling the heat in the company that we have to deliver this program as soon as possible. If he feels this drift, maybe he will be biased towards just approving the code just to get it deployed. But somebody from the outside, he won't care about that. He will do his job. He will evaluate the program in terms of quality. He's going to be fair and just, and you will have a fair idea about the quality of the code. So it's very useful. All right, we've talked about quality, software quality, and we talked about the characteristics of quality software. Right now, and we also talked about the ways or methods or techniques that you can use to enhance the quality of your software. Now we're going to talk about the effectiveness, the relative effectiveness of quality techniques. That means we have different techniques, but of course, some of them are more effective than the others, or some of them are more efficient than the others in certain aspects. Now we're going to discuss them. Okay, the first measure to actually judge the effectiveness of a quality technique is the percentage of defects detected. Simply, for each technique, we can measure the percentage, the number of the percentage or the ratio of the defects that this method detected, right, among all the defects that has been detecting using all methods. And well, of course, makes sense that the method that actually creates or gives the highest percentage, the method that detected most of the defects, is the best one. The thing is, a study has been conducted, and it was adapted, or it was featured in the book Programming Productivity by Jones and Shull at 2002. The study has been done on a very large software project, and it found out that the best technique, the technique with the highest percentage of defect detection, gave only 35%. The best technique gave only 35% of defects detected. That means the best one you have, the best technique they could find, could only find 35% of the defects. That means you should not just rely on one technique to find your defects. You have to use a combination of techniques. You should use many techniques, and together all of them most likely will find all of your defects, or most of your defects actually. So here we're going to talk about the percentage. The thing is, with the percentage of defects detected, you should not rely on just one technique that gave you the highest percentage. You have to use a combination of techniques in order to catch most of the defects in your program. Alright, now we're going to talk about the cost of finding defects. Well, the thing is, as we talked about, there are many ways to find defects or to enhance the quality of your code. But the thing is, some of those ways are just more expensive than the others. They cost more in terms of hours, man hours, which is, of course, transfers into money. Well, the most economical practices result in the least cost per defect found. But the thing is, you shouldn't address this as like, alright, finding bugs or finding defects using the X method cost me like 10 hours, and finding bugs in using the Y method costed me 20 hours. That means the first one is more economical, because you have to take so many things in consideration. First, you have to take care at which stage each of these defects was found, right? Because sometimes the cost of finding a defect in a deeper case or deeper stage is of course more costly than finding it on a lighter stage, because sometimes it's just deeper. You need time to understand the code and to find that hidden bug or defect. The other thing is, of course, you have to take care of the number of bugs found. I mean, if you find 100 bugs in 20 hours, that's better than finding 10 bugs in 10 hours, right? The number of bugs itself counts, and the stage at which each of those defects were found counts also. Actually, many studies have found that inspections are cheaper than testing. Inspections, just going through the code formally or informally, people going through the code, trying to figure out what's wrong with it, if there is something wrong with it, or reading it with the purpose of finding something wrong with the code. Many studies has actually proven that. The book enlists like 3 or 4 of them. We're just going to talk about one. A study was conducted at the software engineering laboratory, found that code reading detected about 80% more faults per hour than testing. That means the cost of doing inspection was far superiorly less than by inspection is superiorly less than by testing, which makes sense. Alright, when we talk about the cost, it's not just the cost of finding the defects, right? Because when you find the defect, you have to fix it. Then we also need to take care of the cost of fixing defects. So the total cost that is associated with defects or bugs would be the cost of finding them plus the cost of fixing them. Well, one might think that it doesn't really matter how did I find the bug. The cost of fixing the bug is going to be the same anyways, right? If I found it the X way or the Y way, anyways, there is a bug and I have to fix it, and the cost of the fixing will be the same. Actually, that's not true, because the longer the bug stays in the system, the more it will cost you to actually fix it. So if you have a technique or a quality technique that will find you bugs earlier in the system's life, it will cost you less when you find them to fix them, right? Because it will be found earlier. So you have to take that in consideration. The longer the bug stays in the system, the more it will cost you to fix it. So this point should be taken in consideration. As a bottom line, as a conclusion to this whole quality assurance thing, we can say that effective software quality program must include a combination of techniques that apply to all stages of development, right? All stages. So here's some kind of a remedy, a recommendation that you can follow about a combination of techniques that you can use to ensure the highest possible quality. Well, inspection of all requirements, design, architecture of all the critical parts of the system, inspection. And well, of course, you have to do modeling or prototyping to sort of testing for the design and the requirements that the design was built on. Of course, code reading and inspection, as we talked about, the code reading, it finds so many bugs and it costs far less when we talk about the cost of inspection versus testing. And of course, you need to do testing to make sure everything works perfectly. Well, the earlier an error is inserted in software, the more entangled it becomes in other parts of the software, and of course, it will be more expensive to remove. If the error is inserted in the software as early as, like, let's say, the requirements phase, then this error will affect the design phase, which in turn will affect the development phase of the construction, and it will be incredibly difficult and it's incredibly costly to remove. But if the error was inserted in a later stage, it will be cheaper or less costly. um, The extra architecture results in extra code, of course, when you actually have an error and you have to modify it, or you have to modify your code in order to fix it. That means you have to write extra code and more test cases because you have messed up with the whole architecture, and you want to make sure that whatever you change now doesn't affect what you have built, the whole time. And more documentation, of course, more, yeah, more costly. Or errors in requirements or architecture tend to be more sweeping than construction errors. Well, that means a single architecture error can affect several classes and dozens of routines. It's not like architecture construction errors, which just affect the method that it was written in, the method or the class it was written on. It just affects a certain functionality of the system. But when there is a mistake or then an error or defect in the architecture or in the requirement, it affects a larger scope. It affects a bunch of classes. Many methods and functionalities will be crippled because of that. Because things are interconnected. That's why it's too cost effective to catch errors as early as you can. Well, defects creep into software at all stages, as we talked about, from requirements to construction, anything. Consequently, you should emphasize quality assurance work in the early stages and throughout the rest of the project. The thing is, when most people think about defects or quality, they think about coding. I mean, when you're writing code, you have to avoid making mistakes. You have to avoid bugs as much as possible. But it's rare when people think about bugs and defects and flaws. Well, when they're talking about requirements or design, because it's not something that is executable. It's not like you can run an F5 or your design or your UML and you got something running. That's why people tend to forget about quality in the early stages. But as we established, it is far more important to assure quality in requirement and design phases than in construction phase. Because if the bug is just some a typo or some minor construction bug, then it will not. It's virtually with no cost at all. It will be easily fixed. But if it's a mistake in the requirements that was elicited from the customer in the design that the whole construction was built on, then it will be a disaster. So the moral of all this is, when we have to do quality assurance as early as possible. We have to start quality assurance starting from the requirements phase. Whenever we start the project, we have to start the quality assurance process with it, just to spare ourselves extra cost if anything went wrong with. Alright, now we're just going to wrap up, just to make sure that all the concepts that we've talked about were clear. First, we talked about we need to identify specific quality characteristics, the things that we can actually use as measures of software quality. And then we talked about how we need to define the project's quality objectives. We need to specifically define what aspects of quality or what characteristics of quality that we need to enhance or focus on. Of course, we need to define external and internal characteristics. We talked about that. We talked about what external characteristics and what internal characteristics are, and different types of each one. We also talked about using different techniques to enhance quality. You shouldn't just use one or two techniques. You have to use a combination of them to make sure that you have detected most of the defects in your system. We talked about starting quality assurance as early as possible in the project's life, because the earlier you start, the more cost you save yourself in the case of having a defect or an error early in the project's life in the requirements or the design phase. which is going to be like astronomical cost if it goes later into the construction phase. The most important result of this whole chapter, that ensuring quality, if you insist, if you think of quality first, instead of thinking of quality as something that you have to strive to achieve after you have done coding, which is a wrong way of looking at things, you have to look at it as if quality is the purpose of your code, the purpose of your system. The first thing that you have to satisfy is that to make quality software. If you think about that, if you try to ensure quality at each stage, it will of course mean additional cost. But think about it as saving money actually, because if you don't care about quality and something went wrong with the requirements or the design phase, and then this error or this defect went of course to the construction and people started coding, and then you found out that there was something wrong with the requirement, in order to mitigate the impact of that mistake, it's going to cost you much 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 more. So think about quality as a way of saving money, not spending money. Alright, so this is the conclusion of this chapter, and I hope you enjoy.